Okay. So my voice is audible? Okay. So in the morning session, we have seen that the conversion of UDL into the point load. We are going through the different types of loads. In that, first we have seen the point load. After that, we have seen uniformly distributed load, and we have also seen that how to convert that uniformly distributed load into the point load. Okay. Now we will move to the next load, that is uniformly varying load. So the next type of load we are going to see now, it is uniformly varying load. So uniformly varying load. This is called as UVL. Uniformly varying load, it is called as UVL. So we can define it as a load which is constantly increasing, or decreasing, throughout the length of the member, is called as uniformly varying load. Okay. So what does it say? That a load which is constantly increasing or decreasing throughout the length of the member is called as uniformly varying load. So constant increase is there, so gradual increase is there. Okay. So if I draw that type of load, here you can see, now this is a member or beam. Here it is again simply supported beam, as we always take. Okay, so this is the simply supported beam. Now if I want to draw the UVL, this is point A, this is B. The unit of uniformly varying load is also same, kilonewton per meter, same as like that of UDL. Now if I draw the uniformly varying load, it may be like this. This type of load is called as uniformly varying load. This type of load, it is called as uniformly varying load. So here you can see the intensity of the loading is constantly increasing. You see, here the intensity is 0 and the intensity is gradually increasing as the length we progress towards the next point. From A to B, if we move from A to B, you can see here the intensity of the load, it is gradually increasing. Okay, constantly increasing. So this type of loading is called as uniformly varying load. This type of load is called as uniformly varying load. So then there are a lot of types. So I can show only the load. This type of load. See, if you see, this type of load is also uniformly varying load. Okay, this type of load. This is also uniformly varying load. This type of intensities will be there. Okay, so this is also uniformly varying load. Its intensity is uniformly increasing up to some point, and after that uniformly decreasing. Reverse of this, mirror image of this will be also there. इकडे intensity जास्त आहे ना, त्याच्याऐवजी इकडे जास्त आणि इकडे zero, असा उलटा ट्रायंगल पण तुम्हाला ड्रॉ करता येईल. Okay, so all these examples are of uniformly varying load. All these examples are of uniformly varying load. Here is I show the support. These are the supports. Here the reactions are RA and RB. Reactions are RA and RB. Point A, reaction is RA. Point B, reaction is RB. So this is the example of uniformly varying load. Is it clear now what is uniformly varying load? Yes, no?
Yes, sir.
Okay. So now we will see how to convert the uniformly varying load into the point load. Okay, now take the screenshot of this and also take down the notes. Now I am going to show it in this figure only, but you have to draw the separate figure for your understanding. Okay. So now, suppose now I will take, for our understanding, what I will do. Suppose imagine that now this span is 6 meter. Okay, arbitrarily I am taking the values, huh? There is no logic. Suppose now this span is 6 meter and this intensity, maximum intensity is 10 kilonewton per meter. This maximum intensity is 10 kilonewton per meter. Now I want to convert that this UVL into the point load. Why I want to convert that? Because in while calculating summation fx, summation fy, and while taking the moment, we require the point load. That is why we want to convert that. So now if I tries to convert it, in the morning I have already told you, while converging the UDL into the point load, area of the load gives you the magnitude. Area of the diagram, loading diagram, gives you the magnitude. Now here you can see this is your loading diagram. In morning session, you know that it was a rectangle. It was a rectangle. UDL is there, then rectangular load was there. Now this is a triangle. It is UVL triangle. So now if I calculate the magnitude of this magnitude, what will be the magnitude? Magnitude is equal to, it is area of this. So area of the triangle is half into base into height. So half into 6 into 10. So it will be how much? 30 kilonewton. So it is 30 kilonewton. This is the point load. This is the conversion of this UVL into the point load. Now from where it is acting? That is the most important thing. From where it is acting. So I will tell you the direct formulas for the CG. Okay, direct formulas for the CG. Now, see, this is the right angle triangle. This triangle is the right angle triangle. Okay. Now we can see where is the CG of this right angle triangle. This right angle triangle is there, and suppose this is the base of the triangle B, and this is the height of the triangle H. Okay. This is the base of the triangle B, and this is the height of the triangle H, and this angle is 90 degree. If you calculate the area of this triangle, area will be half into base into height. This is the area of this triangle. Now where is CG? The CG of this triangle will be situated somewhere here. This is the centroid of this triangle. And if you calculate the distance of the centroid, then it will be B by 3 and H by 3. Now suppose from this end, if you calculate this measurement of the CG, then this base is B. This base is B. So from right angle, it is 1/3 from right angle. From the side of right angle. Right angle जिथे आहे तिथून 1/3 घ्यायचं. Okay, so right angle is here and the base is B. So this is horizontal distance. Horizontal distance base is B. So this is B by 3. This is B by 3. And now if you see the vertical distance, this distance from right angle again, here is the right angle. Okay, so this CG is, this height is H. This total height is H. So from right angle, it is again 1/3. So this will be H by 3. So this is the point where the CG of the right angle triangle is situated. B by 3 and H by 3 from right angle. B by 3 and H by 3 from right angle. Now come back to our case. Now if you see our case, this angle is 90 degree. Okay, so its CG may be situated somewhere here. Okay, now this total distance, if you see, this total base is 6 meter. Base is 6 meter. So this CG will be situated at a distance of how much? This will be, how much is this distance now? किती असायला पाहिजे हे? राईट अँगल पासून कितीवर घ्यायचं म्हणून मी सांगितलं तुम्हाला? B by 3. Correct? So it is B by 3 from right angle. This CG, here is the right angle. Right angle पासून मोजायचं. Base किती आहे? 6. Base is 6 divided by 3. So it will be 2. So this will be 2 meter and the remaining will be 4 meter, as total is 6 meter. So from this centroid, this point load will act. This point load of how much? 30 kilonewton. This point load of 30 kilonewton will act. Okay, so this is the conversion of UVL into the point load. Again, the concept is same. Area of the diagram gives you the magnitude of the force, and The centroid is the point from where that point load is acting. So for rectangle, centroid is at the center. So there is no problem. For rectangle, that is for UDL, your centroid is at the center. But here in the case of right angle triangle, it is not at the center. It is B by 3 from right angle. B by 3 from right angle. You can see if this total is B, that is 6. From right angle, it is B by 3. So 6 by 3, it is 2 meter. समजते का काय चाललंय ते का वरनं चाललंय सगळं काय
समजते
समजताय ना ओके so here you will get the CG आणि तुमचं your concept will become more clear when we will switch on to the numericals सोडवताना तुम्हाला अजून clear होईल okay now see this type of triangle now okay now in this type of triangle now this is not a right angle triangle first thing this is not a right angle triangle so in this type of triangle your CG is situated at here area will be same triangle आहे म्हटल्यावर एरियाचा फॉर्म्युला सेमच राहणार हाफ इंटू बेस इंटू हाईट अगेन सपोज नाव दिस इंटेन्सिटी इज गिवन टू यू and it is 12 kilonewton per meter and suppose now this span is given to you it is let us take that it is 8 meter okay this is given to you so magnitude you can easily calculate magnitude half into base into height formula will be same so half into base is 8 into height is 12 जे काय आन्सर येईल ते तुम्हाला किलोन्यूटन मध्ये लोड मिळेल and CG will be here. CG will be at the center for this type of triangle. This is not a right angle triangle. Okay, this may be isosceles triangle or this may be equilateral triangle. So here in this case, this distance of CG, this is the distance. This is at the center. If I will call this as B, then this will be B by 2. If I call this as a B, 8 meter, then this will be B by 2. 8 by 2 means it is 4. Okay. So normally these three types of triangles are there: equilateral triangle, isosceles triangle, and right angle triangle. So I have told you the formulas for the centroid of all the triangles. For right angle triangle, it is at a distance of B by 3 from right angle. For isosceles triangle or equilateral triangle, it is at a distance of B by 2. Okay, it is at a distance of B by 2. B by 2 means center last. Okay, similar to that UDL for isosceles and equilateral triangle. Okay. So from this CG, your load will act. From this CG, your load will act. So these are the three types of loads: point load, uniformly distributed load, and uniformly varying load. Okay. Apart from this, parabolic load is also there, water load is also there, soil load is also there, snow load is also there. Okay. So many types of loads are there, but for your syllabus now, only three loads are there: point load, uniformly varying load, and uniformly distributed load. Okay, so I have told you the information about all these three loads. If you are having any doubt in these three loads, you can ask to me. If no doubt, then we will move to solve the numericals based on this. So think on this and tell me if you are having any problem. I will wait for some time. Let me know. And if no doubt is there, then you can tell me no, there is no doubt. We can move to the numericals. काय डाऊट आहे का
No, sir.
Okay, no. Only one or two students are saying no. Other anybody is having any doubt? Bakichanna, how many students are there? 55 students are there. Shall we start with the numericals then? If you don't have any doubt.
Yes, sir.
Okay. So we will take the numerical now. Simply supported beam. First of all, before taking the problem, I want to tell you what is the meaning of beam. What is the meaning of beam? Okay, so beam is a member. Beam is nothing but beam is a member which takes the load perpendicular to its length. Okay, beam is a member which carries load perpendicular to its length. Okay, and it has minimum two supports. Okay, so this is called as beam. Minimum two supports. Each called as beam. You can write it further. So what I want to say here, see, a structural member. So this is the structural member, which is having minimum two supports. So these are minimum two supports, which we have provided over here at point A and B. Then it carries a load perpendicular to its length. Now see, if I draw the load, this is the length. This is the length of the beam. This line is the length of the beam. So whenever the load is applied on the beam, it is in this direction. This is the beam. This is the load. Okay. Or if the UDL is there, this is the direction of the UDL on the beam. So this is the UDL. So this will act also vertically downward. Okay. So all these loads are perpendicular to its length. Okay. If the inclined force is given, then you can resolve that force. If the inclined force is given on the beam, then also you can resolve that force. Okay, so you will get one component along the length of the beam and you will get another component perpendicular to the length of the beam. Okay, so the beam is a member which carries a load perpendicular to its length. Okay, perpendicular to its length. So that is called as beam. So if you want, you can write it down. I will give the details over here. W1 kilonewton, W2 kilonewton, these are the loads. W3 kilonewton per meter, this is UDL, point A, point B, this is reaction RA, this is reaction R. So this is the general diagram of a beam. So beam is having minimum two supports. Beam may have more than two supports also. So if the beam is having more than two supports, then it comes under the continuous beam. Continuous beam is not there for your syllabus, but simple beams are there. But at least beam should have two supports. At least beam should have two supports. Now with this note, now we will take the numericals based on this. So the first problem, a simply supported beam of span 6 meter carries point load of 3 kilonewton and 6 kilonewton at a distance of 2 meter and 4 meter from left end, full stop. Determine the reaction at A and B. Okay. So this is the given numerical. By reading the numerical, you have to draw the diagram. Okay, diagram is not given. So here, what they have told us, a simply supported beam. So from this, we can understand that one beam is there. This is the beam, and the simple supports are provided at both the ends. Okay, so at point A is it is simple support provided, and at point B is simple support provided. Then and then only that beam is called as simply supported beam. The meaning of simply supported beam is at both the ends, the support provided is a simple support. Okay, so you will get only one vertical reaction, RA and RB. Of span 6 meter, carries a point load of 3 kilonewton and 6 kilonewton at distance of 2 meter and 4 meter from left end. Now, what is right end and what is left end and what is right end? So your left hand is left hand, your right hand is right hand. Okay, your left hand is left end and your right hand is right end. Okay, here now if I draw the beam, this is the beam. Okay, and now I will show the reactions. Here this is point A, point B. Beam is simply supported. So I will show the simple support here at point A as well as the simple support here at point B. Because the beam is simply supported, it is stated in the problem. So here the reaction is RA. Simple support always gives only one reaction, that is one vertical reaction. So RA and RB I have drawn. Okay. Now A is called as the left hand. A तुमच्या left side ला आहे ना, तुमच्या डाव्या हाताला कोण आहे? A का B आहे? A. So A is called as left hand end. And to your right hand side, B is there. So B is called as right end. Okay. Now see the total span of this beam. The total span they have given to us, and this total span, it is 6 meter. From A to B, the distance is 6 meter. Now they told us 3 kilonewton and 6 kilonewton, 2 point loads are there, acting at a distance of 2 meter and 4 meter from left hand. Okay, so 2 meter is the distance of 3 kilonewton, 4 meter is the distance of 6 kilonewton. So we will take that much of distance now. So from here at a distance of 2 meter. So this may be 2 meter. Okay, so this is 2 meter, and at this point force is acting. Point load सांगितलं त्यांनी problem मध्ये. In the problem they have specified that point load is there 3 kilonewton. Again at a distance of 4 meter. So from this point at a distance of 4 meter, so somewhere here, okay, at this point somewhere here 6 kilonewton. Okay, so this distance is 4 meter and total is 6 meter. Now what they have asked us, they told us to determine the reaction at A and B. To determine the reactions at A and B. Now how to calculate that reaction at A and B? What we will do now? See here there is if you apply summation fx equal to 0 here, you will not get anything. या प्रॉब्लेम मध्ये आत्ताचा जो दिलेला प्रॉब्लेम आहे, प्रॉब्लेम बघून तुमच्या लक्षात यायला पाहिजे बरं का. सो सी इन दिस प्रॉब्लेम देर इज नो इन्क्लाइन लोड, म्हणजे हॉरिझॉन्टल डायरेक्शनला तुमचा कुठला लोड येणार नाहीये. रिएक्शन इज ऑल्सो नॉट एनी रिएक्शन इन द हॉरिझॉन्टल डायरेक्शन. सो लोड पण हॉरिझॉन्टल डायरेक्शनला नाहीये आणि रिएक्शन पण हॉरिझॉन्टल डायरेक्शनला नाहीये. सो व्हॉट डज इट इंडिकेट दॅट समेशन एफएक्स मध्ये कुठलाच फोर्स येणार नाही, कुठलीच क्वांटिटी येणार नाही. ओके, सो समेशन एफएक्स even though if you use here, you will not get anything. Two equations are remain. Summation Fy equal to 0 and moment at any point equal to 0. Okay. Moment at any point equal to 0. So if I apply summation Fy equal to 0 first, समजा मी ठरवलं की summation Fy आधी वापरू, तर काय होईल जर मी Fy वापरायला गेलो तर त्याच्यात RA येणार, 3 kilonewton येणार, 6 kilonewton येणार आणि RB येणार. आणि RA आणि RB दोन्हीची व्हॅल्यू आपल्याला माहित नाही, म्हणजे आपल्याला प्रॉब्लेम सॉल्व्ह होणार नाही समेशन Fy वापरून. पण काय होईल, एक इक्वेशन मिळेल. वी विल गेट वन इक्वेशन इन RA अँड RB इफ वी अप्लाय समेशन Fy इक्वल टू 0. सो समेशन Fx वापरून काय फायदा नाही. इफ यू अप्लाय समेशन Fy इक्वल टू 0, यू विल गेट वन इक्वेशन इन द फॉर्म ऑफ RA अँड RB. सो इट इज बेटर to go with the moment. So it is better first we will apply the moment at any point equal to 0. Okay, so now to begin with I will take this point A, okay, and I will apply summation M about A is equal to 0. Clockwise movements are positive anti-clockwise movements are negative. Now here you can see this RA is passing through point A. So the perpendicular distance of RA is 0. So the moment of RA will be 0 because the distance is 0. Next force is this 3 kilonewton. What is the distance of this 3 kilonewton from A point? It is 2 meter. So its moment will be 3 into 2. Now it is positive or negative. Now see This 3 kilonewton is moving down. This 3 kilonewton is moving down. याला थोडं खाली ओढा आणि पॉइंट कडे रोटेट करा. थोडं खाली ओढायचं आणि पॉइंट कडे रोटेट करायचं. बिकॉज इट इज मुव्हिंग डाऊन ना, तसंच घ्या त्याला खाली आणि रोटेट करा पॉइंट कडे. सो व्हॉट इज द डायरेक्शन? क्लॉकवाईज or anti-clockwise?
Clockwise.
Clockwise. So this is plus. This is plus. Similarly, this will also we will get plus. This 6 kilonewton. याला आपण थोडं खाली घेतलं आणि A कडे वळवलं. So this is the direction. This also clockwise. This is also clockwise. Now 6 kilonewton is the force. And what is the distance from point A? Because we have taken moment at point A. So we need to calculate the distances of all the forces from point A. So from point A, the 6 kilonewton force is at a distance of 4 meter. So if it is at a distance of 4 meter, then your moment will be 6 into 4. 6 into 4. Then, now this RB. What is the distance of RB from point A? It is 6 meter. Distance is 6 meter. It is moving up. जाऊ द्यायला थोडं वर घ्या. वर चाललाय ना. What is the direction RB? RB is moving up. We have assumed that RB is upward. त्याला थोडं वर घ्या आणि रोटेट करा. वर घ्यायचं आणि रोटेट करायचं. कशी येते डायरेक्शन? क्लॉकवाईज or अँटी क्लॉकवाईज? So it is minus 6 RB is equal to 0. Therefore, now if you solve this, 3 into 2, 6, 6, 4, 24, 30. RB किती येते? RB 5 kilonewton. बरोबर आहे का? 3 into 2, 6. 6 आलं इथं. 6 into 4, 24. 24 plus 6, 30. 30 is equal to 6 RB. तिकडे पाठवलं तर. Therefore, RB is equal to how much? 30 by 6. So 5 kilonewton. And we have got the positive answer. So our assumed direction of RB is correct. It is moving upward. Our assumed direction of RB is correct because we have got the positive answer. If we get the negative answer, then we need to change the direction of RB in that case. So here we have got the positive answer. This is the value of RB, 5 kilonewton. Now after this, apply summation Fy equal to 0. Now apply summation Fy equal to 0. Upward forces are plus, downward forces are minus. So now if I apply that, then what I will get? First is this force Ra. It is moving upward, positive, plus Ra. This 3 kilonewton force moving downward, so minus 3. This 6 kilonewton is also moving downward, so minus 6. And this RB is moving upward, so plus RB. ओके. मोमेंट मध्येच आपण फक्त डिस्टन्सनी मल्टिप्लाय करत असतो हे लक्षात ठेवा. मोमेंटचं इक्वेशन घेतल्यावरच डिस्टन्सनी मल्टिप्लाय करायचं. जेव्हा जेव्हा तुम्ही समेशन एफ एक्स अँड समेशन एफ वाय हे इक्वेशन वापरता, ऍट दॅट टाइम इन समेशन एफ एक्स यू शुड कन्सिडर ओनली फोर्सेस which are parallel to x-axis in summation fx, and in summation fy you should consider the forces which are parallel to this y-axis, vertical forces. Okay, distance आपण fx आणि fy, f stands for force. फोर्स असल्यावरती डिस्टन्स आपण कधी घेत नाही. आणि एम स्टँड्स फॉर मोमेंट. मोमेंट जेव्हा असेल तेव्हाच डिस्टन्सनी मल्टिप्लाय करायचं. एवढं लक्षात ठेवा. हे इक्वेशन वापरलं तरच डिस्टन्सनी मल्टिप्लाय करणार तुम्ही, अदरवाईज नाही करणार. Okay. Now, if I apply summation Fy equal to 0, then Ra is moving upward, plus Ra, minus 3, minus 6, plus Rb. So value of Rb is 5, plus Rb equal to 0. Now it is Ra minus 3, minus 6, plus 5 is equal to 0. Therefore, Ra is equal to, what is the answer? 4. Okay. Positive वाला का negative वाला answer?
Positive.
Positive. So our assumed direction of Ra is correct. Ra also moving upward. So our assumed direction is correct. So these are the reactions Rb and Ra we have calculated. See the numerical. Let me know if you are having any problem or any doubt. काय प्रॉब्लेम आहे का? Okay. So shall we move to the next problem if nobody is having any doubt?
Yes, sir.
Okay. So now we will take the next numerical. Now I will add some UDL into the problem also. Okay. A simply supported beam of 10-meter length carries UDL, uniformly distributed load, and 2-point loads as shown in figure. Now figure is given to you as shown in figure. Full stop. Calculate the reactions RA and RB. Calculate the reactions RA and RB. A simply supported beam is given to us. Now I will draw the diagram. So this is the simply supported beam. It is simply supported. So here the simple supports are given. Simple support is having only one reaction, that is vertical. So I have drawn the simple support. Here it is point A, point B. Here at this point reaction is RA. At this point reaction is RB. Then the total length is 10 meter. Total length of the beam is 10 meter. So this total length, this is 10 meter. This total length is 10 meter. Now on the beam loading they have given to us, and the loading is in this way. Here is the point load. This is a point load of 50 kilonewton. And it is at a distance of 2 meter from A. This is at a distance of 2 meter from A. This is 2 meter. This is 2 meter. Okay, this distance is 2 meter. So now second, another point load is there somewhere here, and which is at a distance of 4 meter from left end. The magnitude of this point load is 40 kilonewton, and it is at a distance of 4 meter from this end. This is 4 meter. Okay, and whatever the middle portion is there, in this middle portion they told us there is UDL, and the value of this UDL is 10 kilonewton per meter. And now what will be the span of this UDL? What will be this length? If this total is 10, this is 4, this is 2. So 2 plus 4, 6. 10 minus 6, 4. So remaining this length, it is 4 meter. This is. Now we want to calculate the reaction at point A and reaction at point B. Okay. So simple problem is there like the previous problem. Only the UDL is added in the numerator. So first, as usual, we will take the moment, because we know that if you apply summation fx over here, if you apply summation fx, you will not get anything because there is no horizontal force, no horizontal reaction. Now if you apply summation fy, what you will get? You will get RA is also unknown to you, RB is also unknown to you. So now if you apply summation fy, you will get the one equation in RA and RB. Okay, so instead of calculating the equation, we will take moment. So I will take the moment at this point, A equal to 0. You can also take moment at B0, no problem. मोमेंट ऍट ए ला 0 घ्यायला पाहिजे असं काय नाही, तुम्ही बी ला पण 0 घेऊ शकता, पण ए आणि बी या दोन्हीपैकी एकाच पॉइंटला मोमेंट घ्या. आर यू गेटिंग माय पॉइंट? मी तुम्हाला असं का सांगतोय की आयदर ए पॉइंट आणि बी पॉइंटलाच मोमेंट 0 घ्या, इथं पण पॉइंट आहेतच की. सपोज नाव दिस इज माय पॉइंट सी, दिस इज माय पॉइंट डी. ओके, आणि सेंटरला जो काय पॉइंट असेल इथं सेंटर बीमचा, तिथं पॉइंट ई आहे समजा. सपोज दॅट इज पॉइंट ई. बट आय एम टेलिंग you should either take the moment at point A equal to 0 or you should take the moment at point B equal to 0. Why I am telling this for this numerical? Can you tell me? Anybody can explain me why? समजा मी या सी पॉइंटला जर मुवमेंट घेतली तर काय होईल? ए ला मी घेत नाही मोमेंट 0, ए च्या ऐवजी जर सी ला घेतली तर काय होईल?
व्हॅल्यू अननोन येतील.
व्हॅल्यू अननोनच राहणार ना. हे बघा, जर मी सी पॉइंटला मोमेंट 0 घेतली, काय हे 50 किलो न्यूटनची मुवमेंट 0 होईल, ह्याची काहीतरी मुवमेंट मला मिळेल, या 40 ची मुवमेंट काहीतरी मिळेल, आणि RA इंटू 2 ही पण मुवमेंट मला कन्सिडर करावं लागणार, कारण RA 0 होणार नाही जर तुम्ही सी ला मुवमेंट घेतली तर, आणि RB पण 0 होणार नाही जर तुम्ही सी ला मुवमेंट घेतली तर. म्हणजे त्या इक्वेशन मध्ये तुम्हाला RA आणि RB हे दोन्ही मिळणार. ओके, RA and RB you will get both, and unnecessarily you will create it complicated. So my suggestion is, when you come across the numerical, you see that at support which type of support is given, and you should always take the moment at either of the support. जर तुम्ही A ला मुवमेंट घेतली तर RA 0 होईल, RB ची व्हॅल्यू डायरेक्ट मिळेल. जर तुम्ही B ला मुवमेंट 0 घेतली, समेशन ऍट B इक्वल टू 0 केलं तर RB 0 होईल आणि RA ची व्हॅल्यू तुम्हाला मिळेल. ओके, so that is why I am telling you, take always the moment at any of the support. So now if I take the moment about A equal to 0, all my clockwise moments are positive, anti-clockwise moments are negative. Okay, so now see, RA is passing through point A, so RA's movement will be 0. Next is this 50 kilonewton. The distance of this 50 kilonewton force is 2 meter from A. So it will be 50 into 2, and it is plus because it is moving in clockwise direction. Now this UDL means what? It is the uniformly distributed load. It is the uniformly distributed load. So we need to convert that UDL into the point load first. If we want to convert that UDL into the point load first. So how do we convert? We will take the area of this. Area of this means this is a rectangular load. Intensity is 10. Span is 4. So it will be 10 into 4. 10 into 4. Right? 10 into 4 म्हणजे काय मिळाल तुम्हाला? Magnitude of force. This is the conversion of UDL into the point load. Now I know the value of the point load. It is 40 kilonewton. 10 into 4. This is my point load. This is not a moment yet. Just I have converted UDL into the point load, and that point load is 10 into 4. 10 into 4 is point load. This is point load. Okay. Now see where we are taking the moment. We are taking the moment at this point. Now 10 into 4 is a point load. That point load will act through the CG of this 4 meter. This 10 into 4 point load will act through the CG of this length. So this length is 4 meter. So that load will be act at the center over here. Okay, if I show you the load, that load will act somewhere here. Okay, this will be the load. This is your 10 into 4 load. Conversion of UDL into the point load. Okay, now this will act somewhere here. So this distance will be 2 meter, and this is also 2 meter. So from point A, its distance will be 2 plus 2. It is 4 meter. So its movement will be, you have to multiply it by 4. So this is the moment of UDL about point A. This is the moment of UDL about point A. समजतंय? हे डिस्टन्स किती राहणार आहे तुमचं? हे असणार आहे 2 मीटर, कारण हे टोटल 4 आहे. 4च्या सेंटरला हा लोड येणार आहे, म्हणजे हा डिस्टन्स किती झालं? 2. इकडे ऑलरेडी किती आहे? 2, कारण आपण मुवमेंट कुठे घेतोय? A पॉइंटला. सो वी शुड मेजर the distance from point A only. So if you measure the distance from point A, this distance will be 2 plus 2. It is 4 meter. कळलंय का?
Yes, sir.
10 into 4 into 4 कुठून आलं हे जर कळलं तर तुम्हाला युडीएलचं पॉइंट लोड मध्ये कन्व्हर्जन करायला काही अडचण येणार नाही कधीच. पण हे नसेल कळलं तर आत्ताच विचारा. यू कॅन आस्क मी राईट नाव. आय विल एक्सप्लेन यू वन्स अगेन.
सर एरिया ऑफ रेक्टँगल कळला ना फर्स्टला ती?
हा, 10 into 4 मीन्स एरिया ऑफ रेक्टँगल. ओके, ह्याला जर मी तुम्हाला दाखवलं ना खाली, समजा दुसरी आहे बघा, ही मी डायग्राम काढून दाखवतो. एवढाच सेक्शन दाखवतोय 4 मीटरचा. हे 4 मीटर आहे आपलं, आणि इथं असा हा युडीएल म्हणजे असा रेक्टँगल असणार आहे, असा असणार आहे. ओके, दिस इज द रेक्टँगल, and this intensity it is given as 10 kilonewton per meter. So what is the area? 10 into 4. area is 10 into 4. This is our magnitude of the force in kilonewton, and it will act through the CG of this rectangle. Has a CG कुठं असणार आहे? If this total is 4 meter, then this will be 2 meter from this side and 2 meter from this side. Okay.
Yes, sir.
हा, हे 10 into 4 into 4 कळलंय का नाही कळलंय?
कळलंय सर.
मग तुम्हाला कळलंय काय? रिपीट करायची गरज आहे का कळलेलं आहे? अजून एकदा सांगा मला.
कळलंय सर.
तुम्हाला कळलंय? बाकीच्यांना काय म्हणताय? ठीक आहे. ओके. तुम्हाला मी सकाळी सांगितलं होतं, काय शिकवलं होतं? Whenever UDL is there or UVL is there, area of the diagram will gives you the magnitude of the force. बरोबर आहे? एरिया ऑफ द डायग्राम. आता तुम्हाला UDL इथं असा दाखवलाय. UDL हा का जो आहे, that UDL is shown like this, but actually UDL is nothing but it is rectangular load. So I can imagine over here a rectangle because UDL is a rectangular load. Okay, it's a rectangle असणार आहे. So how to calculate the area of rectangle? It is length into width. So length is 4 meter. This width intensity किती दिलेली आहे? 10 kilonewton per meter. So it will be 10 into 4. So this is the 10 into 4. So this 10 into 4 is my point load. It is not a moment. This 10 into 4 is my point load. How do I get that point load? I have converted this UDL into the point load. And how I converted? I multiply this intensity with the length. I multiply this intensity with the length. That is what I got the area of this rectangle. Then only. Then 10 into 4. This 10 into 4 is my conversion of UDL into the point load. Sir, 10 into 4 is my conversion of UDL into the point load. And now this point load will act at the center of this UDL. आता UDL ची लेंथ किती आहे? 4 मीटर आहे. त्याच्या सेंटरला ऍक्ट होणार आहे, सेंटरला. म्हणजे इकडनं 2 मीटर आणि इकडनं 2 मीटर वरती असणार. बरोबर? इट विल ऍक्ट ऍट द सेंटर. सेंटर मीन्स व्हॉट? सेंटर मीन्स its distance is 2 meter from this side. Okay, and 2 meter from this side also. This is what is the meaning of center. So 10 into 4 is not a movement. You remember this. This is my point load. This I have converted UDL into the point load. And then this is the distance by which I have multiplied. This is the distance I have which multiplied. म्हणजे point load ला मी परत या डिस्टन्सनी जेव्हा मल्टिप्लाय केलं त्यावेळेला मला मुवमेंट मिळाली. हे 10 into 4 म्हणजे काय? माझं पॉइंट लोडच आहे. हे UDL चं कन्व्हर्जन आहे पॉइंट लोड मध्ये. ओके, म्हणजे जर रेक्टँगल काढून जर तुम्हाला सांगायचं म्हणलं तेवढाच याचा, तर बघा हा रेक्टँगल आहे. ही जी लेंथ आहे, दिस लेंथ इज 4 मीटर. नाउ फॉर दिस डायग्राम, only for this much of portion I am drawing the diagram, only for this much of portion. So now this 4 meter here, if I show you this type of load is given to you. Okay, and the intensity of this load, it is given to you as 10 kilonewton per meter. Okay, so if I calculate the area means what? It is length into width. So length is 4, width is 10, it will be 40 kilonewton. Now my force is 40 kilonewton. So from where this force will act? This force will act through the CG of this rectangle. To the CG of this rectangle. Where is the CG of this rectangle? If this total is 4 meter, then the CG will be at 2 meter from this end, and from this end also it is at distance of 2 meter. CG will be at the center. Okay, म्हणून हे जे मी दाखवलं ना, this distance is 2 meter. मग हे 4 कसं काय आलं? तर हे डिस्टन्स 2 मीटर आणि हे पुढचं 2 मीटर. म्हणजे ए पॉइंट पासूनचं डिस्टन्स किती आहे टोटल? 4. कारण आपण मुवमेंट कुठं घेतोय? ए पॉइंटला, म्हणून डिस्टन्स ए पासून घ्यायचं. तुम्ही ज्या पॉइंटला मुवमेंट घेताय त्या पॉइंट पासून डिस्टन्स घ्यायला पाहिजे. ओके, so that is why now where CG is over here, so this point force will be acting like this. This is your force of 40 kilonewton. Okay, and this distance is 2 meter, and this is your point C over here. This is your point C. हा तुमचा point C आहे, and this is your point D, which I have shown here, D point. Okay, is it clear now? Everybody, have you? हा, समजलं का नाही? Yes, sir.
Yes, sir.
ओके.
Yes,
फक्त
sir.
कन्फ्युजन कशात होतंय सांगतो तुम्हाला. जेव्हा नुसतं पॉइंट लोड असते की नाही असं 50 किलोमीटर, आता इथं बघा 50 किलोमीटर 50 इंटू 2 केलं की तुम्हाला डायरेक्ट मुवमेंट मिळते इथं. हे काय झालं, फोर्स इंटू परपेंडिक्युलर डिस्टन्स. पण ज्या वेळेला युडीएल येतोय की नाही युडीएल, तर त्यावेळेला तुम्हाला आधी त्याला पॉइंट लोड मध्ये कन्वर्ट करावं लागतं. म्हणजे आधी एक मल्टिप्लिकेशन तुमचं येणार आणि ह्या आलेल्या पॉइंट लोडला हा 10 इंटू 4 म्हणजे काय आहे, ही मुवमेंट नाहीये. 10 इंटू 4 म्हणजे हे 10 इंटू 4 म्हणजे हा आहे पॉइंट लोड. आणि ह्या आलेल्या पॉइंट लोडला तुम्हाला परत डिस्टन्सने मल्टिप्लाय करावं लागणार, मग तुम्हाला मुवमेंट मिळणार आहे. ही गोष्ट फक्त लक्षात ठेवा. पॉइंट लोड असला की डायरेक्ट मिळतं तुम्हाला, डिस्टन्सने मल्टिप्लाय करता येते. पण युडीएल असलं की डायरेक्ट मिळत नाही. तुम्हाला आधी या युडीएलला असं पॉइंट लोड मध्ये कन्वर्ट करावं लागेल आणि मग त्याची मुवमेंट घ्यावी लागेल बाय मल्टिप्लाइंग बाय डिस्टन्स. ओके. So now moving further into this part. So here now I will rub this all these things. Okay, so here it is 10 into distance is 4. Now see this UDL is also acting vertically down. UDL is also acting vertically down. हा जो UDL आहे हा डाऊनवर्ड फोर्स आहे सगळा. ओके, जर ह्याला थोडं खाली ओढलं मी, समजा डाऊनवर्ड फोर्स आहे ना, थोडं खाली घेतलं आणि रोटेट केलं पॉइंट कडे. इफ आय टेक इट in downward direction and rotate it about the point, what is the direction? What is the direction? Clockwise. So it is plus or minus then? Plus. Okay, so this is for UDL. Now again the force of 40 Newton, 40 kilonewton. Now see, here is the force of 40 kilonewton at point D and we are taking moment at point A. So from point A, this total distance AD, this is 2 meter, this is 4 meter. So total distance from A to D is 4 plus 2, 6 meter. So its moment will be 40 into 6 and it is positive. And lastly, minus means for this RB I am talking about, because it is moving upward. So when you rotate it about the point A, it will rotate in anti-clockwise direction. So this is minus. What is the distance? Total A to B distance is 10 meter. Total distance is 10 meters. So I can write here minus 10 RB is equal to 0. Therefore, now if you solve this, you will get the value of RB and let me know the answer. What is the answer?
34.
34. देते हैं 15 into 200, 10 into 4 40, 40 into 4 160, 260, 260 plus 240. It is 500. चेक करा बरं अजून एकदा आन्सर. RB is equal to
50 kilonewton.
5050. पॉझिटिव्ह मिळाला आन्सर का निगेटिव्ह मिळालं? पॉझिटिव्ह. सो आवर डायरेक्शन इज करेक्ट. RB आपण जे अपवर्ड ऍज्युम केलेलं आहे, वी हॅव ऍज्युम दॅट RB इज मुव्हिंग अपवर्ड. So our direction is correct. RB is upward. So this is the value of RB. So now apply summation Fy equal to 0. So upward force is plus and downward force is minus. So now if you apply this, what you will get now? RA is moving up, so plus RA, minus 50 is moving down, so minus 50, minus this UDL is also moving down. So what is the value of UDL? 40 kilonewton. 10 into 4. 40 is a load. 10 into 4. So this is 10 into 4. This is point load. Again, this is not a moment. 10 into 4 is not the moment. 10 is the intensity. 4 is the length. So it is force, point load. Okay. Minus this 40 is moving down. So minus 40 plus this RB is moving up. So plus RB, which is equal to 0. Therefore, RA is equal to 80 plus or minus
Plus.
plus. So again, our assumed direction is correct. So here I want to ask you, here I have taken this 10 into 4, this term. Have you understood this? This is important. इथं तुम्ही बघा नुसतं 50 फोर्स घेतलाय. समेशन एफ वाय म्हणजे काय? फोर्स पॅरलल टू वाय. मगाशी मी तुम्हाला सांगितलंय एफ स्टँड्स फॉर फोर्स. इन फोर्स यू शुड नॉट मल्टिप्लाय बाय द डिस्टन्स. म्हणलं ना, इथं 50 बघा, नुसतं 50 लिहिलंय, 40 नुसतं 40 लिहिलंय, आरबीची नुसती व्हॅल्यू ठेवली. ह्यालाच का 10 into 4 केलंय? हे कळलं का? आर यू गेटिंग माय क्वेश्चन?
Yes, sir.
सांगा ना मग उत्तर मला. हे 10 into 4 म्हणजे काय? हा पॉइंट लोड आहे का मोमेंट आहे तेवढं सांगा. तेवढं कळलं तरी बाद झालं.
पॉइंट लोड.
कळलं? म्हणजे इथं 10 into 4 जरी आपण लिहिलेलं आहे तरी कन्फ्युज होऊ नका. दिस 10 into 4 इज नॉट अ मोमेंट. This 10 into 4 is the conversion of this UDL into the point load. Ultimately, we are considering all these point loads over here. Reaction म्हणजे काय? Reaction म्हणजे सुद्धा एक point loadच आहे. Okay. So all these point loads we are considering in summation Fy, and same thing we will do in summation Fx also. We only consider the point loads. So that is why we have converted this UDL into the point load. That is why this term is come over here, 10 into 4. आणि आता जसं मी केलंय ना, ते असंच तुम्ही करायची सवय आत्तापासून राहावा. माइंड मध्ये कॅल्क्युलेशन करायचंय. त्याच्यासाठी उगा परत सेपरेट डायग्राम काढा, UDL ची डायग्राम, रेक्टँगल काढा, मग ते दाखवा, त्यात वेळ घालवायचा नाही. डोंट वेस्ट युअर टाइम इन दॅट. ओके. सो मेक दिस हॅबिट राईट फ्रॉम द फर्स्ट प्रॉब्लेम. माइंड मध्ये कॅल्क्युलेट करता यायला पाहिजे. इथं दिसली ना इंटेन्सिटी, वेन यू सी दिस इंटेन्सिटी 10, वेन यू सी दिस स्पॅन 4, 10 into 4, 40. हे तुमच्या डोक्यात यायलाच पाहिजे. 40चा माझा पॉइंट लोड असणार आहे. फक्त आता तो कुठे ऍक्ट होईल? दॅट 40 पॉइंट लोड विल ऍक्ट ऍट अ सेंटर ऑफ दिस 4 मीटर. लेंथ बघायची युडीएलची, किती लेंथ आहे? 4 मीटर. तर त्या 4च्या सेंटरला येईल. जर युडीएल पूर्ण स्पॅनवर दिला असता 10 मीटरवर, तर 10च्या सेंटरला आला असता, म्हणजे 5 वर. Okay, so in this way you should convert this UDL into the point load. Okay, clear now? Clear झालंय का?
Yes, sir.
Yes, sir.
Okay, so now we will take the next numerical then. वेळ संपली का? Okay. Instead of taking the next numerical we will take on the Monday. I will give you one problem for the homework. You have to solve this numerical. आणि सॉल्व्ह करून या. इथं आल्यावर मी विचारल्यावरती उत्तर सांगा. इट इज गुड फॉर यू इफ यू सॉल्व द प्रॉब्लेम. बिकॉज अल्टिमेटली एक्झाम तुम्हालाच द्यायची आहे ना. सो हिअर this is point A, this is point B. Here is reaction RA, this is reaction RB, and this total length is of 8 meter. And here, this is the point load acting. This point load is of 10 kilonewton. The distance of the point load is 2 meter. Okay. Then up to this point UDL is there here. The UDL is of intensity 15 kilonewton per meter and the span of UDL is 3 meter. Then here at this point, okay, and here at this point an external moment is acting. Okay, नको तेवढं complicated पुढच्या problem ला घेऊ. So these two, one point load and one UDL is given to you. Okay, you have to solve this numerical. And to make it somewhat more complicated, what we will do, let us take here one UVL. This intensity is again 10 kilonewton per meter, and whatever the span 3 plus 2 5, so this is 3 meter, and it will acting like this. Okay, now you have to calculate the reaction RA and RB. Calculate the reaction RA and RB. This is your homework problem. Tomorrow is Sunday, so you have ample time. Just a single numerical is there. So on Monday, please give me the answer of this question. Okay. So today we will stop over here. Give the attendance. Roll number 1, 2, 3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6. Roll number 6, 7,
Present, sir.
8,
Present, sir.
9, 10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present.
17,
Present, sir.
18. Roll number 18. Morning lecture also she was absent. Okay, 19, 20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31, 32, 32, 33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present.
41,
Present.
42,
Present.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47, roll number 47, 48, 49,
Sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56, 57,
Present, sir.
58,
Present, sir.
59, 59, 60,
Present.
61,
Present, sir.
present. Okay. So roll number 6
Sir,
is
48 is present. Actually, my network connection has lost.
okay. 48 is also present. So I will announce the absent roll numbers. If somebody is present from those roll numbers, you can tell me. Roll number 18, roll number 32, 47, 56, and 59. These are the today's absent roll numbers. Anybody from this roll number who is present over here? Okay, no one is there. Okay, so one more thing I need to announce over here. In the morning, I have told you that your ISC paper 6 marks MCQ will be there and 12 marks 2 problems will be there. So 12 plus 12, 24 and plus 6, 3 questions I have told you. In that also, it is also the possibility that in the offline examination, if you see, you will get the maximum marks for the numerical is 8. Maximum marks for the numericals is 8. Then so that what we will do then, question number 1 will be for 6 marks, 2 will be for 8 marks, 3 will be for also 8 marks, and 4 is also for 8 marks. So instead of 2 questions of 12 marks, 3 questions will be there, each will carry 8 marks. Okay, that 8 marks is the highest weightage for the numerical in the offline examination. So in that way, we have planned according to this year new syllabus scheme. Earlier it was used to be for 12 marks. Now it is for 8 marks. Okay, so in this way now we will do it. Okay, so is it clear now?
Yes, sir.
Okay.
Yes, sir.
Okay, so you prepare for both the formats. You have to prepare for the numericals, also the theory questions, that parallelogram theorem, Lamis theorem, then Varignon's principle. Okay, we have seen all these things. Then what is force? What are the characteristics of force? What is scalar quantity? What is vector quantity? So this theoretical part you have to read. It is already, most of the theoretical part is already covered in the 12th. तोच तुमचा most of the part repeat आहे. त्यानंतर नवीन गोष्टी ज्या आहेत ते Varignon's theorem आहे, parallelogram theorem आहे, law of polygon आहे, law of triangle आहे. Then your Lamis theorem is there. Law of transmissibility of force is also there. So these theoretical questions, and then numericals on unit 1 that you have already already, it is there in your notebook. And this numericals now almost we are taking all the variety of problems in unit number 2 also. Okay, so now in the Monday or on Monday, maybe if on Monday if our lecture is there, then your second chapter will get over. Okay, so first and second chapter will be there for your ISC. So prepared well, चांगला अभ्यास करा आणि चांगले मार्क घ्या. Okay, so we will stop over here for today.